Okay, so we were looking at energy changes, and the first thing we defined was temperature. Okay, we defined temperature as the average kinetic energy of particles, all right, of any gas, and blah blah blah. We did quite a number of definitions. We did heat of reaction. We spoke about activation energy and activated complex. Just want to add one definition for you on that heat of reaction. Heat of reaction is the energy absorbed or released per mole. I want us to write that down. Heat of reaction. Energy, I'll write it somewhere here. Energy released or absorbed per mole in a chemical reaction. Heat of reaction, energy released, which is also our enthalpy, energy released or absorbed per mole. That's very important, per mole. That's why you see us writing kJ per mole, kilojoules per mole. And then we spoke about our what? Exothermic, a reaction where heat is what? Released in form of energy. Endothermic, heat is absorbed. So we looked at all of those things last week. So we just want to answer questions and end this week. It's a very short topic. Yes, talk to me. There's a hand.
So we also want to do those
yes, questions. Yes, we're going to do all of them just now. So we are racing. Hence, I said, I hope you did. Okay, we did some last week, right? All right, guys, there we go. I need multiple choice answers. Today is just about this, answering questions. I'll give you 3 minutes. You got to read through. No, but wait, did we take pictures of these things last week? We did. Robert Liz, yeah, he's trying to share me. We sent, yes, we did. So, yes, so it should have been done. So there's no need to start wasting time because it's going to waste our time. We just need to answer. Please, in case you did not do it, I know that it's hectic at school. Find time, because once I start giving you 3 minutes, 2 minutes, 10 minutes, we do less. But I want us to do all of it. Okay. When sulfuric acid reacts with water, the temperature of the reaction mixture increases. That's very important. Increases. Which one of the following correctly describes the heat of reaction, which is delta H, between sulfuric acid? What's your answer here? Delta H. Can I start getting answers? A, B, C, D? A, B, C, D, E, F, G, H, I. Yeah, here, B. Rose, B. Are you also saying B now?
I know I wrote B.
Okay. Guys, the correct answer is B. Okay. Please remember that this is what? Heat of products. Don't forget, heat of products and heat of what? Reactants. And my delta H is always the heat of product minus the heat of what? Reactants. That's why we have P1 minus P2. Number 1.7. The chemical reaction that represents an endothermic. Oh, beautiful. I love this. Endothermic. Which one will it be? Come, answer us quickly. Endothermic. Oh, thank you. Thank you. Diobo gave me an A, which is correct because of that. So the correct answer is A. Remember, endo, our delta H is positive. Beautiful. All of these three are saying the same thing. Okay, please, all well stated last week. Beautiful. We have a question here. Learners study endo and exothermic reactions by conducting experiment 1 and 2, in which the reactions shown in the table below takes place. Okay, we have that. The learners measured the initial and final temperatures of the reaction mixtures. They also obtained activation energies for the reaction from the data. The learners represented their findings in the table as shown. So we have that. Oh, beautiful. Look at something here. Experiment 1, 24 to 36. May I quickly ask you something here? Sorry. 1.2, is it an endo or an exothermic? That graph.
The one that takes the same to 4 days.
Is it an endothermic or an exo? That's very important. Okay, I see answers coming. Thank you. Tejo, I saw your answer. This is exo what? And I want you to look at something. Check. The temperature of the reaction mixture does what? That's a very important point. The temperature of the reaction mixture increases. Okay. You will see what I just told you now. Temperature 1. Initial is 24, final is 36. Temperature 2. 24 and 18. Define the term activation what? Energy. That's a copy and paste. What is that? All right. It's the minimum what? Energy needed to what? To start a reaction. That's a copy and paste answer. 5.2. In which experiment 1 or 2 is the reaction exothermic? I want the answer to this one. Which one is exo, 1 or 2? River says 2. You still with your answer? Okay. Everybody says 1 except you, child.
No, wait.
Oh, wait, there's a 2. Yeah, here, I see a 2 here. Was that an old answer? Yeah, here says 2. Okay, you and Yaya says you're saying 2. The answer is 1. And that's why I took you back. Come, I took you back to this so that we would sort this out. Check here. What is this? The temperature of the reaction mixture does what? Increases. That means it becomes hotter. So the final, wait, I'll tell you why you are confused. This is not heat of reactants. That's what's confusing you. So the temperature of the system does what? Increases. That would be exo. Didn't I write that for you? Wait, hold on. Didn't I give you that? Let's go back. If we don't have it, we add it to it. Let's go back. I need your notes to be well detailed so that when you are reading exam. Okay. Exothermic is a reaction that releases heat in the environment. There's excess heat. So that means it's now hotter. All right? E.g. combustion. But let's put that note there in black and white. The temperature of the reaction mixture increases. That's why some would then be released. The temperature of the reaction mixture, I want that to be in black and white under your exothermic. Okay. So we are sorting that out. And what would be our reason here? And that's the reason anyway. Exothermic. Which reaction? Reaction 1. Why? Remember, these are temperatures. This is not energy. Okay. What are we saying here? Temperature increases. So the reason why we say it is exo is because it produces more energy than needed so it gives it away. Okay. Explain your answer with that. Is the heat of reaction delta H positive or negative for an exothermic? Now we are answering that enthalpy. Delta H is less than 0, which means it is what? Please, the answer is the negative, not the less than 0, because they said state positive or negative. Write down the general name of a substance that can be added to the reaction mixture in experiment 2 to reduce the activation energy. That's a catalyst. Do you see it's 1 this thing you do it in 5 minutes. Once the content is in place, we're good. Okay, 5.5. Both reactions produce the same amount of moles. How does the mass of hydrogen peroxide H2O2 used in experiment 1 compare to that of experiment 2? Write down smaller than. Okay, let's go. They said both reactions produce what? The same number of moles of oxygen. Both reactions produce the same number of moles of oxygen. If they produce the same number of moles, then we are using, if you look at hydrogen peroxide for both of them and oxygen, it's ratio 2:1. So if they produce the same number of moles, it means we are using the same thing here. All right? I don't know if we're going to just use the same. Whether it is exo or endo really doesn't matter. Remember I told you, okay, no, that's a different thing. But in terms of quantity, it doesn't really matter. It only means one happens faster than the other. So quantitatively, it actually is the same. Why? How does the math? Because they told us it is producing the same number of what? Moles. Draw a potential energy time graph for the reaction of 2, which is what? What is your 2? Endothermic. Show the guys, I'm not going to draw. Okay, let's draw. I'm sure you know what that looks like, right? For endothermic, what are we going to have? It will be like that. And then we have but please label it. This is what? Amount of energy in kilojoules per mole. What are we showing? H reactant and H what? Product. They said we should show delta H. Where's our delta? It is right here. What are we showing again? Activation energy. Remember, the activation must be measured from the reactants. What's on the y-axis again? Progress. It's in your books, right? I just copied the same diagram. So it's in the note we had last week. We just copying and pasting. That's gone. 12 marks now. The diagram shows the potential energy changes during the following reactions. We have that. Okay. I'm not going to define activation energy again. Is this exo or endo? Do you want to help me here? Is this endo or exo? And what would be your reason? Because I can't see energy increase here. What's your reason? The heat of products is less than the heat of what? Reactants. That's what I can see from the graph. I cannot calculate for now. What is the total bond energy, H2 and Cl2, of the reactants? Total bond energy. Now, that's a very good question. Please watch this. The total bond energy of hydrogen and chlorine. Total bond energy. How are we going to answer that? Let me see. Did you guys respond to that? How did you answer that? Total bond energy. Huh? Share your answers with me. I'll give you, let's see, let me give you 2 minutes to try to think. Huh? Nah, it's not enthalpy. Total bond energy. Sorry, I thought my mic was on. All right, I was saying that now the total bond energy means energy required to break the bonds. Bond energy. So what's what required to break? And until the reactions break, then reactions cannot start. So that is basically activation what? Energy. And my activation energy, remember, we measure it from what? The reactants to the what? Activated what? Complex. So that is the bond energy. Okay. That is the bond energy. 6.4. Another calculation there. 6.4. Just want to confirm something. Which one? Because of the reason. They said give a reason, right? Okay, beautiful. That's why I love doing questions. Things that I didn't mention then will start popping up and I don't like it. Okay, but anyway, these are not common questions. Okay, so we said it is the energy needed to do what? To break the bonds. Now, what are we looking for? Our next question says what? Calculate the... Now, let's see something here. To form the bond, what do we need? When bonds are formed, so remember, bonds are first broken, then the bonds are then formed after passing through the activated what? Complex. Is that okay? So this is going to be energy released from bond formation. So bond formation would be this. Let me explain something to you here. So when we have this graph, let me actually draw something here quickly. This is very, very important. It's probably skipped my mind when I was giving you the notes, but I'm glad we're here. Okay, let me put it here. So when I have this, for example, I know this is H of what? Reactants. And this is H of what? Products. Okay. Just a quick labeling. And that would be what? My delta what? H, which is my enthalpy. And this becomes my what? Activation what? Energy, right? Okay, please watch this. There are two energies that I want us to quickly deal with here. I'm just glad this question came up now. Now, the energy here is the bond energy. The energy on the side is the formation energy. Please check. Bond energy, we are breaking the bonds on that side from the reactants. But we are forming, so can you see it goes to activation energy, activated complex, and then that's when we start forming the products. So that whole length is called formation energy, while this one is called what? Bond energy. This is breaking the bonds. Energy required to break bonds, and energy required to form what? Bond formation. I think this would have, if I had given you this note, it could have solved this problem. It could have solved this problem. To break the bonds, we start from the reactant, and to form the bond, it's on the product side. Yes, yeah, EA is only from the reactants. Oh, yes, my graph. Oh, look at me. EA is from the reactants. I get what you pointed out now. Thank you. This one is wrong. Remember, if you remember the definition, is the energy required to start. And where do you start from? You start from reactants. We don't start from products. We start from the reactant. That's why our EA is always from there. Thank you for seeing that. Okay, I think we can answer this question now. Are we done drawing? We can answer now very quickly. There's just one little trick. Okay, can we go now? Okay, now, so let's answer. So what do you think the bond formation would be? It would be what? 184 plus what? 679,1. What would that give us? No, 0.7. 184,7 plus 679,1. What would that give us? 863, what? 8 kilojoules. Okay, but hold on. I want you to see something here. They said, determine the energy released by the bond formation of the HCl molecule. How many moles of HCl did we form? 2 moles. So this one is for what? 2 moles of what? HCl. Now, so for 1 mole, what do we do? It's going to be 863,8 divided by 2. And what would your answer be? 431,9. Can you see? Kilojoules per mole. 1 mole. Kilojoules per mole. I hope it makes sense. Okay, and that's it then. What effect will the addition of a catalyst have on the value of 184, a catalyst? Check. What would a catalyst do? If you just remember the graph, it would move from here you see that it has nothing to do with it. It only affects the activation what? Energy. But that one is the energy of the product. So, what's your answer? No effect. What would be a reason? Not really. Only the activation, and just because we are talking about the energy. So let's talk in terms of energy. Only the activation what? Energy is reduced. The heat of reactant and heat of product are not tampered with. Okay. Heat of reactant and heat of product not tampered with. And I think I did mention that, right? Yep. Even delta H is not tampered with. I remember giving you that. Let's see, just for confirmation. There we go. Heat of reactant, heat of product, delta H does not change. Okay. So the note is enough ammunition to assist you. Let's look at this one quickly. The following reaction between ammonia and oxygen takes place in a closed system at constant pressure and temperature. Define activation energy. I'm just tired of defining that, right? Give a reason why this reaction is exothermic. It's exo. Either you can calculate delta H here. All right? There are so many. But I don't want to calculate it because 7.3 tells me to calculate it. So 7.2, I would say the heat of product is less than the heat of what? Somebody doesn't even understand what I mean by it's less than. Please check. What is the heat of product? 183.3. What is the heat of reactant? 400. That's what we mean. Because when I say heat of product minus heat of reactant, I'll get a negative one, and which is my 7.3. Write the formula first. Delta H equals to what? The heat of products minus the heat of reactants. 183.3 minus 400. What's your answer? 216.7 kilojoules, don't forget, per mole. 7.4. Redraw the graph and indicate with a dotted line the effect of catalyst. I think it's in the note again, but for doing sake, it is exothermic, so that should be higher and that lower. Dotted lines. Remember, this one does not change. And this one does not change. So, okay. Heat of reactants and heat of what? Products. They told us to use dotted lines to show what? Activation. That's the pathway. We must show the activation energy. EA catalyst. Okay. State Avogadro's law in words. Do you remember that? 1 mole of any gas will contain the same what? Volume at the same temperature and pressure. That's now we're going into stoichiometry. Avogadro's law, grade 10. No, but I did state it when we're doing, don't lie to me. Yeah, I did. 1 mole of any gas will occupy the same what? Volume at same temperature and pressure. This is where we talk about STP 22,4. Didn't I do this question? Okay, guys, I'm going to ask you to do this because I did something similar. Let me take you back. Let's go back to that question and then come back to this in case you didn't do it. Let's just take a quick step back. The one that I used the table. In fact, it's exactly the same question. They only change the centimeters. 60 centimeter of ammonia reacts completely with 90 centimeter cube of oxygen at the same temperature. Calculate the total volume. And now look at this one. It's practically the same thing. This examiner just copied and pasted. Look, 6 dm cube of ammonia and 9 dm cube of oxygen are used. Calculate the total volume of the gas. Okay, let me go through again. All right, just for, and I won't use a table this time. I won't use a table. Okay, let's check. So we have 4 moles of ammonia, right? Reacting with 5 moles of oxygen. Now, 6 dm cube of ammonia and 9 dm, everything is by molar what? ratio. So if I check my ammonia and oxygen, it is 4 to 5. Now, if I use 6 of this, okay, guys, can I ask you a question? And nobody's asking me a question. Why am I instantly considering ammonia as a limiting reagent? Because limiting reagent is what determines the rest. I didn't even do any calculation to say which one is limiting. I just chose ammonia. Every time I react something with oxygen, and I did mention it as well, it is combustion reaction. So basically, ammonia is burning. And when combustion happens, it burns in excess oxygen. So please take note. Combustion occurs mostly in what? Excess what? Oxygen. That's why I just went straight to say ammonia becomes because oxygen is in abundance. All right, how many moles will so 6 would then be what? What would it be? If 4 moles is to 5 moles, so I'm converting straight, and I'm saying then 6 dm cube ratio n. So, no, since it's volume, I'm using volume straight. What would this be? The volume of oxygen. 7, all right, 7,5. It means oxygen left will be 9 minus 7,5. I hope that makes sense. That is 6 moles has reacted with what? 7,5 moles. Out of 9, we are left with 1,5. Then we go to, last week I used a table. Huh? Okay. 4 to 4 mole ratio. Oh, it means 6 would be to what? To 6. It means we have 6 moles, or not, let's say volume of NO. Volume of nitrogen monoxide will be what? 6 moles. That is produced. I'll go back to the table, and Vater 4 to 6. But I have 6 there. What is the volume produced here? 9. Because that will be 36 divided by 4. So volume of water is 9. Total volume would be what? 9 plus 6, 15. 15 plus 1,5. 16,5 dm cube. Let me use the table. Let me show you the table. I'm not going to re-explain all of this, but I'm just going to use the table for us to see what this that I did mean. Maybe the table will help somebody a lot better. If I go to the table, everybody, quickly. You see the answer, 16,5. Check this. So these are the things we have, right? 4, 5, 4, 6. We started with 60 here and 90 there. Mole ratio, that's what we're doing. That 4 to 5, 60 will be to 75. So it means I used 75 and I'm left with what? 15 from 90. But these ones are 0, 0. You know why? They are products. At the beginning, we don't have them. Again, mole ratio would give us just exactly what we did. 4 to 6, 60 to x. X would be what? 90. 4 to 4, 60 to x. X would be what? 60. So what do we have? We're forming 15, we're forming 60, and we're forming what? 90. So the total volume of gas, 15, 60, 90. Do you know why? This one has been used up. It is a limiting what? Reagent. It has finished. This one is excess because combustion happens in excess what? Oxygen. I hope we're good, everybody. So this was last week. We used the table. And this week I decided let's walk through stoichiometrically. I hope it makes sense. So this is actually the same thing. It's just to clean the zeros. Divide everything by 10. 6, 9, 7,5, 1,5. Pa, 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 pa. Okay. Alrighty. We're doing good with time. Ooh, we have 3 questions. Yes, talk to me.
Please go back to the previous slide. My question is from there.
Which one? This one? This is where we are.
The table one that you were referring to.
What's the question?
Are we able to explain once I see the table? Yes, sir. Despite most of oxygen, and then you said that the initial is 90 or, and then we end up getting 75. But now for H2O, there's 6 moles, but we still get 90. How does that work?
What do you mean? The 90 here is the 90 that was given.
Yes, sir.
Yes. And we, out of 90, we use 75 here. Oxygen. 4 to 5, so 60 to X. 75. So we used 75 out of the 90 given. For oxygen, 4 to 6, 60 to X, gave us 90. It means we produced 90. 4 to 5 is 60 to 75. 4 to 6 is 60 to 90. You are looking at these two 90s and you're getting confused.
Yes, sir.
No. We didn't get this 90. It was given.
Yes, sir.
So, ratio-wise, 4 is to 5, 60 would be to 75. Ratio-wise, 4 is to 6, then 60 would be to 90.
Oh, okay.
You get the whole idea?
Now it makes sense.
So we used 75 out of the 90 given, but we then produced 90 because it's higher. 4 to 6 is higher than 4 to 5.
Okay, thank you, sir.
All right. The next question is a grade 10 one. I'm sure you know. It's a grade 10 one. What do I mean? The reaction above is the first step of the manufacturing of an acid, ammonium sulfate. This acid contains 1.5% hydrogen, 22.2% nitrogen, and 76.2% oxygen. Determine the empirical formula. Do we remember how to do empirical formula? It is hydrogen, nitrogen, and what? Oxygen. Oh, nitric acid. Percentage by mass, 1.59, 22.2, and 76.2. This is mass by what? Percentage. Now, what is the atomic mass? 1, 14, and 16. Can we divide? 1.59 over 1, 22.2 divided by 14, 76.2 divided by 16. Quickly give me answers. I know this one. 1.59. 1.5857, which is basically 1.59, which will be 1. This will be what? 3 point something. Stop lying, child. Huh? What do you have?
I have 4,7656.
4, comma? 4,7625. Okay, there's a hand or something there. Guys, is there a hand or is there an answer? Okay, what do we do? Divide by the smallest. So what do we have? Ratio. So 1.59 divided by 1.59 will be 1. 1.5857 divided by 1.59 will also be 1. 4,7. I think that should give us about 3. Three, right? So empirical formula is HNO3. Free 5 marks for everybody there. This is a mark booster. And now you can see that this topic is not hectic. It's something you can get. Guys, are we okay? Next week I'm doing acid and base. Please don't miss any section there. Grade 12s are joining on that session. It's completely acid and base, grade 11 to 12. It's going to be so detailed. Okay. Really now, I'm not doing this one. No. If I do this, I'm abusing you. Don't you say that I'm abusing you if I do this one? Like honestly, define act. First, look at the reaction. Again, the equation of combustion. Combustion means it is burning. Once you see combustion, it is exothermic because it's burning. Is the combustion exo or endo? Exo. Why is it exo? Delta H is, you'll use the information given. Delta H is what? Negative. Because it has been given. Sketch the graph. I think we've sketched that enough today. Empirical formula. Who has a challenge with 7.4? Can I skip? Your answer should be CH4. Huh? Yeah, especially if you understood that one that we did. This is a practical repetition, repetition. Now you know that definitely 7.1. So if you get that wrong, it's on you now. It's not on anybody. All right. We go back to our stoic here. X grams of sodium carbonate react with 0,02. This is so important, guys. And I don't think we did. We didn't. I gave it to you, though. It was long ago. We're supposed to answer it last week. Okay, then we skipped it. Okay, so most of you should have answers to this. Okay, define the time limiting reagent. We've been talking about that again so many times. Reactants that is used up in a we're supposed to answer it, remember? Oh, name the law. Avogadro. That's what we stated. 1 mole of any gas occupies the same volume at the same temperature. They said we should name it, so it is Avogadro. For me, I think I'm only interested in the stoichiometry now, Determine by calculation which substance is there. Okay, how would we do this? Okay, but let's go back. What do we have? Remember, we don't even have sodium. We don't have anything about sodium carbonate. But we know that sodium carbonate reacts with what? 0,028 mole of hydrochloric what? Acid. Guys, the best thing is to always write out your equation. So Na2CO3 plus what? 2HCl to give us NaCl plus CO2 plus H2O. Okay. Now let's go back. X grams. So this is X grams. React with, what do we know? 0,028 moles of hydrochloric acid. Let's check. Which is what? Number of moles. Lovely. Now it says 448 cm cube of carbon dioxide gas is produced. I'm just transferring all my information. Volume produced is what? 4. Please, the unit is very important. Cubic centimeter produced. Okay. And the molar volume, they're giving us a molar volume of what? This is why you must convert. Somebody say, why should I convert? Win. Please check. Look at the volume they gave you. Look at the molar volume. So we must always convert our cm cube to what? Cubic decimeter. All right, molar volume is 24,27. Let's just put that down. Now remember, if we divide this, what would this be? 0, please know how to convert. Divide by what? 1,000. Now here is our question, quickly everybody. Determine by calculation which substance is the limiting what? Reagent. Look, we actually know nothing about the other one, but let's see something. Since we are producing this one, let's convert it to number of moles. I'll show you. We're reversing it. So number of moles of CO2 is volume over what? Molar volume. What do we have? 0,448 divided by, this is the volume produced. What's your answer? Volume produced. Zero comma?
0,184.
I missed 1 0, right? 0,184 moles. Is it fine? 185 moles of what? Carbon dioxide is produced. Okay, Praise, your hand was up. Because that's what, remember, that's what we're given. Why not 22,4?
Yes, that's what I was asking. So why not 22,4?
In this question they're giving us.
They already gave us this.
Yes. If they said at STP, then we would use 22,4.
Yes.
Okay. Now, let's see something here. I'm producing this number of moles, but I only have information about what? HCl. Let's check something. If I compare HCl and carbon dioxide, which I have, you can use any of the two. 2 moles of this should produce what? 1 mole of that. Now, if you can decide to use whether carbon dioxide or, but let's check something. If I were to use this, since I produced that, how many moles should I have used to produce this? What would it be? The number of moles we cross multiply of HCl required will be what? 2 times 0,0185. What would that be? Is needed. Check. I need 0,037 to produce 0,015 moles. But how many moles do I have? I have 0,028 moles of HCl. Which one do you think is the limiting reagent now? Can I get an answer from you guys if you understood what I did here? The question says that 0,448 0,185 is produced, right? For me to produce that 0,0185, I actually need 0,037 moles. But what I have for HCl is 0,028. Do you think the HCl is the limiting reagent? Do you think so? You sure? I don't think so. I don't think so. Why not?
Because we need more.
Okay, wait, hold on. Before I give you a conclusion, hold on. If I have 0, I want us to see it correctly together and be on the same page, right? if I have, let's use HCl to calculate. So HCl and what? Carbon dioxide, right? 2:1. Are we right with the ratio? Okay. Now, it says we have 0,028 moles of this. Watch this. If we use 0,028, what should we be producing? We should be producing 0, what? But aren't we producing less? Except check your calculations again. Just check your calculation again. 448. Please just check again quickly. I need to run now. 0.448 divided by 2427. I just need to balance it so that we are all on the same page, you know. Oh Lord, I'm tired. It's correct? Okay. It's the same. All right, let's reason together here, everybody. Do you still think HCl is the limiting? Because if I use 0,028, I'm going to be producing 0,056 of carbon dioxide. But now, do you notice I am producing less than that? Yes, Nolwazi? I want to, before you make a Nolwazi, talk to me.
Excuse me, sir. I wanted to ask how you got the 0,056.
Cross multiply. No. Oh, we're supposed to divide. Sorry, divide. End would be what? 0, what? Is that fine? More, sorry. I went to cross multiply. Of what? Okay. So we're saying, if I have 0,028, right? Let me put that down for you. 0,028 moles of HCl should produce 0,014 moles of carbon dioxide. That's standard. But how many moles did I produce? I produced 0,018. Do you notice that the HCl is not actually the one controlling? I don't know if that makes sense. Please talk to me. I need us to get this page done. If this is the only question I do on this Tokyo for now, then I just want to make sure we agree.
But then I don't need to do that other side.
So, please guys, I need all your responses. Please share your confusion with me, because I'm trying to do both sides to see, because we need to agree on one answer from both ends. Both ends will give me the same answer. Which one is my limiting? From the left hand side, I'll take you through again. What we said was 2 moles of this will always produce 1 mole of this, right? Now, we have produced this. We cross multiply to produce 0,185, which was produced. We need 0,037. So it means this guy was not the one controlling that thing there. Am I right? Because if this was the one controlling, then this one should give me this. And limiting reagent is what controls your output. Do we agree? Here's where I stand, and you tell me where you stand. HCl is not my limiting. If you agree with me, thumbs up. If you don't agree with me, thumbs down. If you are confused, give me a teary face. I need that response in 5 seconds. Quickly, please. It's like I've been able to sway everybody. I'm a good politician. But does it make sense though?
Honestly, we aren't.
Limiting reagent. So my limiting reagent controls everything. But let's see something. The examiner said we should find the mass of X. I'm going to come back and see. Calculate. So for me, I'm saying sodium carbonate is my limiting. Because it's what determines the end. All right. Calculate the value of X. Now I know the end. Right? I know the end. So now that I know the end, I will then work directly with the end. What am I looking for? I'm looking for mass. Oh, why did I clean this? Okay, beautiful. Now, Na2CO3 and what? CO2. What's the ratio? How many moles was produced? 0,0185. N. It means the number of moles of sodium carbonate also is what? 0,0185 moles by cross multiplication. But number of moles is mass over molar mass. Yes, so we are correct with that conclusion we made. We don't know the mass. Now, what is the molar mass of sodium carbonate? Sodium is 23 times 2. Carbon is 12. And oxygen is 16 times 3. Please give me an answer as quickly as possible. We are done with the question. Maybe we can do one more. There were 3 of them. I need to rush out at 50. 50 grams. So this is what controlled or determined my quantity of product. Don't tell me you have a wrong answer now. Wait, in an exam, who's going to check for you?
I'll double check.
Huh? Guys, what are you getting? One comma? Okay, guys, those of you at home, I don't know whether your calculators are on holiday, but you're not getting me answers. 1 comma? I need to know whether we're correct here, because I'm not using my calculator. She's checking again. Repeatedly, if you change this answer right now. Okay, okay, you have saved. They've saved you there. Because if you, but guys, did my argument make sense? Because I needed to be able to do the conclusion that I did. The product is always determined by what? The limiting what? Reagent. So the limiting reagent is sodium carbonate. So limiting reagent is sodium what? Carbonate. That's why I wanted to show you from the 2 different ends so we get the same answer. Oh, shame. Sorry. Okay, let's see if we can do the last one in 10 minutes or so. Okay, oh, I need to run. Yes, I see percentage purity there. Come, let's do this. Sodium azide is used in car airbags. For the airbags to inflate, the following reactions must take place. We have a reaction. Calculate the volume of nitrogen gas. So always have an idea of what you're looking for. We're looking for volume there. That will be produced at STP. Now, that is where I am going to be using my molar volume as what? 22,4. If 55 grams of sodium azide reacts completely, check, completely means it is the limiting what? Reagent. Guys, I'm looking for, look, a quick stoichiometry step. What am I looking for? Volume. But how would I get that? Number of moles is volume over molar what? This I have. This they won't give you. You know that. I'm going to have to get it from here. 3 steps of stoichiometry. Number of moles is mass over molar mass. Mass over, what is the mass? 50. What is the molar mass? 23. Nitrogen is what? 14 times 3. Please give me an answer as quickly as possible. Please don't use the 2. The 2 is not, that's not where we use the 2. A lot of people always confuse that 2. 7692 moles. Lovely. Now I come to my step 2. If you remember all the steps, molar what? Ratio. Yes, talk to me there. There's a hand.
So I used 55.
Oh, sorry.
I got 0.85.
I wrote 50. 55. It's my fault now, not Rubotli.
Yeah, I was so confused.
0, comma?
461. 462.
85.
85 462. Okay, I like to at least go 4 decimal places.
0.846.
Oh, 0.8462.
Yeah.
Okay, don't round off yet, Michelle.
Okay, sir.
All right. Now 2 to 3, but I know this is 0.8462 and n. Cross multiply. 2n equals to 3 times 0.8462. Do you want to give me n? Divide both by 2.
2.58. I mean 3.
2 comma
384.
moles of nitrogen gas. Then my third step, number of moles is volume over molar what? Volume. 2,5384. I don't know my volume, but I know my volume as 22,4. And we are done. 5 marks quickly.
56.86.
And your unit, cubic what? Decimeter. Are we okay with this? Straightforward stoichiometry. This is elementary entry level. This is stoichiometry light, you know, before we go to Stoichio Pro. Yes, Michelle?
You seem to have forgotten to divide by 2. Because I took 0.8462, multiplied it by 3, and then got your final mole answer, but I then divided it by 2 in order to get what Umar just posted, which is 1.2.
No, wait. Is the number of moles here correct?
Yes, sir. The number of moles that we are working with isn't correct because we need to divide it by 2 again.
2n equal. Wait, 2n equals to 3 times that. Did you divide by 2 already there? You sure? I don't, because that's where the child, I'm going to destroy someone. Okay, give me the answer now. 1, 2693. Okay, guys, it's not me. Who? It's giving me the answer. Oh, okay. All right. So what's the final answer?
28.243 decimeters cubed.
All right, cubic decimeter. All right, anyway, but it's the step that really matters. Okay. All right, thank you. All right, guys, let's look at the last question quickly. I hope it's the last one. Yes. And then we're done. 40 grams of impure calcium carbonate reacts with 200 cubic centimeter. There's a problem there. Please, we stop reading. What is that? Divide by 1,000, 0.2 cubic decimeter. All right. Of dilute sulfuric acid with a concentration of 1.5 moles per dm. Can you see dm? All the calcium and sulfuric acid react completely, leaving the impurities behind. I did mention impurities don't react. All right. Calculate the percentage what? Purity. Let me quickly copy and paste this question. What is the formula for percentage purity? Do you remember? Oh no, what am I doing? Do you remember the formula for percentage purity? I'll remind you so that then we use that as a guide to what we need to do. What is the formula for percentage purity? Percentage purity is mass of what is pure over total impure sample times what? I know my impure sample already has 40 grams. So I need to get what reacted. Guys, just move. We are looking for mass. Very easy. We are looking for mass here. Of what reacted, rather. Okay. What did they say? What are we given? We're given that what? The number of moles here is what? No, we don't have number of moles. What do we have? Concentration is what? 1,5. What's the volume? I'm looking for the mass here. And to get mass, what do I need? I need the number of what? Moles. Stoichiometry is done already. You can see from your sulfuric acid that C equals to what? N over V. 1,5 equals to N over 0,2. What's your answer there? 0,3 moles of sulfuric what? Acid. Right? Instantly, what do I know? Mole ratio. Oh, beautiful. It is 1 to 1, right? So if this is 0,3 and this is N, the number of moles here is what? 0,3. Can we convert this into mass quickly? Number of moles is mass over molar mass. 0,3. Calcium carbonate should be 100. Calcium is 40. Carbon is 12. Oxygen is 16 times 3. 48, 12, 60, 40, 100. 100 times this will give us what? 30 grams. Percentage purity. So we are saying only 30 grams is pure. Out of what? 40. I think I did this question. That's your flow. Did it make sense? That's our flow. So the formula will always guide you. Mass of pure substance over total sample of impure multiplied by 100. Beautiful 6 marks once you know your stoichiometry. Number of moles is always the problem. And we use mole ratio to transfer that number of moles. Can I look at the last question? And then safely we can fly. No, I cut it into 2. Safely we can look at acid and base next week. Please don't miss it. I'll be starting from like the basic. All right, look at the next one. To obtain, let me cut it so that we have space. So it's a sequel, it's a continuation. To obtain the sulfuric acid of concentration of 1,5 moles per dm cube that reacted with impure, okay, this is more of acid and base. They said to obtain that, 10 cm cube of the concentrated sulfuric acid of that 9 moles per dm cube was added to what? Water. Let's understand. Calculate the volume of water required. Please, let's understand. We have concentrated, it's like your Oros. And you want to make dilute. So what do? You add your concentrated to what? Water. And that should give you what? The dilute. Watch this. What do we know about the concentrated part? What is the concentration? 9 moles per cubic decimeter, right? Lovely. We were told that 10 cm cube was taken. What is 10? 0,01. Yes, dm cube. Is that okay? Okay, please check. 10 cm cube was added to water. All right. Now the question says calculate the volume of water required to dilute the concentrated sulfuric acid. I'll be dealing more of this on when I do acid and base. I'll come back to this question, but we're going to answer it now. Our concentration here is what? 1,5 what? Moles per dm cube. Here is the dynamics of that. Please, I want you to listen. Am I not missing something? When we dilute something, let me do it this way. Guys, if I take a cup of tea and I put 5 spoons of sugar in it and put half water, we're going to say it's very sweet, right? Lovely. If I pour more water, what am I doing? Diluting. But does it remove the number of sugar present? No. So tell your parents, it's the same amount of what? Sugar. Now that is the idea of acid and base. I'm going to clean this quickly. I was just trying to get the information. So for diluting, this is the key thing that I need us to write, but we'll look at it again. The number of moles in the concentrated is the same number of moles in the dilute substance. Like what I just explained. You put water in Oros, don't deceive yourself. You are drinking the same amount of sugar. Okay. Now what is N? Remember that C equals to N over what? V. So what is N? CV. So concentration and volume of the concentrated is the same as concentration and volume of the what? Dilute. Are you with me? Now check, my good learners. Do I know the concentration of the concentrated one? 9. Do I know the volume? They said 10 cm cube of the concentrated 0, what? 0.1. Do I know the concentrated of the new value of the new one? 1,5. But I don't know the volume. Please get me volume of the dilute substance quickly. Then I'll explain something just to close here. Divide both sides by 1,5. 0, all right. Okay, guys, please watch. If I take water and dilute with Oros, what do I have at the end of the day? I have a diluted what? Oros, which is the dilute solution. Please watch this. The dilute volume is the volume of the concentrated plus the volume of the water. I don't know if it makes sense to you. Talk to me. Huh? It doesn't make sense. Volume of the, please let me know if it makes sense. Volume of the dilute is the volume of the concentrated plus the water. You take 2 teaspoons of Oros and pour it in the cup and you add water. What do you have in that water? It's the concentrated and the water, which makes the whole dilute system. I don't know if it makes sense. So 0,06, 0,01 plus volume of what? Water. What is the volume of water that was added? 0,05 dm what? Cube. Let me know if it makes sense. Yes, question quickly. We've got 3 minutes.
So this can really quickly re-explain when we did on the left-hand side.
Okay, I was saying that if you have a cup of tea, right? Keep your mic on. I want to go forth and back with you. And I put in 3 spoons of sugar. Now, the 3 spoons becomes my number of moles, right? And I have a volume. With that, I have a concentration. Is that okay?
Yes, sir.
Now, I decide to add more water. What am I trying to do when I add more water? I'm diluting, right?
Yes, sir.
If I then dilute, do you notice that my number of moles remain what? The same.
Okay.
Because
I get it.
it is still what? 3 spoons.
Yes.
But the first one was concentrated, the second one is dilute, but the 3 spoons remain the same in both. Hence we said the number of moles in the concentrated is the same as the number of moles of what? The dilute. Don't worry, acid and base, I'm going to come back to this, is part of acid and base.
Okay, thank you very much.
But we're okay, make sense? All right, guys, we okay? No questions? Acid and base, we'll come back to this one. Do you add water to acid or you add acid to water? It's not the same. Yes, we would learn that under acid and base. When you want to dilute, are you going to pour water into the acid or you are going to pour acid into the water? No, it's the same. I'm going to get the same result at the end of the day, but one is not safe. The reaction of acid and water is always very rigorous. So it's like throwing a stone. If you throw a stone in water, what splashes? Water. That's the same story. So if I pour water in acid, the first drop will splash acid, which is not safe. But if I pour acid in water, the first drop of acid will splash water, which is safe. So we are, it makes sense, right? So that is the dynamics. But don't worry, acid and base is going to be guys, please learn it now. When we get next year, I'm just going to say, go and watch your notes for last year, please. It's very detailed. My grade 12s are coming in because I'm not revisiting that with them again. We are doing everything full blown. All right, guys, have a lovely day and see you again next week.